This is Srihari, lecturer in physics in RGR Academy. Now I am going to discuss about the electric fields. Electric field, any field, two physical quantities will there. One is the vector quantity, another one is the scalar quantity. So it may have the first we will discuss what is the field. It is a space around the charge. It is a space around the charge in which the effect of the charge can be detected. It is the charge, in this charge surrounded by how much space charge effect will there, that we are saying the charge field. It is the region of space in which the effect of the charge can be detected, that is the electric field of this charge. So every field, it has the two physical quantities. One is the intensity, it is a vector quantity. Another one is the potential, that is the scalar quantity. In the electric field, electric intensity. In the gravitational field means gravitational intensity. It may have the magnetic field means magnetic field intensity or magnetic field induction. So it may have the potential conditions also same. In the electric field, electric potential. It may magnetic field, magnetic potential. Gravitational field, gravitational potential. The same similar will there. So now we want to discuss about the electric intensity. See here, electric intensity. Electric intensity, due to this charge, wherever the point and that point, what is the intensity will there. So that we want to find it. So it may have the electric intensity. Simply we are saying the electric intensity means of force per unit test charge. Electric intensity E is equal to force per unit test charge. Simply we are saying electric intensity at any point in an electric field is force per unit test charge, force per unit test charge. So it may have the E is equal to F by Q naught. F is equal to force, Q naught is the test charge. It is its SI unit is Newton per Coulomb or volt per meter. Newton per Coulomb or volt per meter. It may have the dimensional formula of the electric intensity. It is there mL T power minus 3 I inverse. Some people they may using I place it the A inverse also. Electric intensity due to a point charge. Electric intensity due to a point charge. Electric intensity, we are considering a point charge. So due to this point charge, electric intensity at any point. We may consider one point here, that point is the P at a distance R from the charge, from the capital Q charge. Electric intensity from the capital Q charge. So see here, due to this charge, due to the capital Q charge, electric intensity we are finding at P. So first we want to find the force at P. Force at P. So what is the force in this point P is F is equal to 1 by 4 pi epsilon naught Q capital Q naught by R square according to Coulomb inverse square law. According to Coulomb inverse square law. In this case, we know that definition of the electric intensity. Definition of the electric intensity. What we last part we discussed. Electric intensity. Electric intensity, the force by unit charge or force per unit test charge, that we are using here. So force for electric intensity E is equal to force for unit test charge. Using these two equations, we may write E is equal to 1 by 4 pi epsilon naught Q naught by R square divided by Q naught. So Q naught cancel. E is equal to 1 by 4 pi epsilon naught Q by R square. It is the magnitude of the electric intensity due to a point charge at P. It is electric intensity due to a point charge capital Q at a point P. Okay. So, it may have the electric intensity is a vector quantity, its direction is always, it may have the charge is the positive in the force direction, it may charge is the negative, electric intensity direction is the opposite to the force direction. Thank you.